Yes. The topic we are going to discuss today, that is state change. Okay? Actually, this is another impact of being heating a system. For example, when you are going to heat up a system in first state, what did you observe? कि अगर आप किसी सिस्टम को हीट अप करते हैं, you are supplying the energy, you are adding some energy to that, so that will cause the change in temperature, yani its temperature would be increased. And now the second aspect of that is, when you are going to heat up a system, yani you are going to add some energy to that, it would change its state. State can mean that if it is the solid, it would be melted. If it is liquid, it will be boiled. In the same way, if you are going to extract the heat, the process would be reversed. So I will discuss that in detail, inshallah. So melting and boiling is the first state in which we provide the heat. When you provide the thermal energy, what happens? The objects are changing their state in this way. It is short topic, don't get worried about that. Let's see, this is a diagram in which you people would make a very clear difference, that if a solid is being heated, it will melt, and if it is further heated, this is addition of energy, on the left side. So when it will be further heated, it will basically boil. Melting takes place at melting point, is it? And boiling takes place at boiling point. So melting point is that temperature at which the solid melts or it freezes. When you take the energy away, what happens? The gas would condense to liquid, and when it would be further cooled down, I mean energy is further extracted out, it would be frozen, and it would be solidified. So, for example, if it is ice, if I'm going to melt the ice, what would be the melting point of that? 0 degree centigrade, na? So at 0 degree centigrade, ice will be converted into liquid, and at the same 0 degree centigrade, your ice will, yani your water will be frozen to ice. Remember one thing, that melting point and freezing point are the same point. In the same way, boiling point and condensation, they are the same points. Is it? For example, if I'm talking about the water, this is, let's say, water. So water will be boiled at 100 degree centigrade. And if I want to decrease the temperature of the water, I mean, if I make to extract the energy, then at again at 100 degree centigrade, what will happen? It will be condensed. So remember this concept, that basically the liquid gases, liquid can be, yani liquids are boiled, gases are condensed, solids are melt, the liquids are frozen. So this is basically the situation when you have to yani talk about that. Uh, Very important thing, which is very important, I have mentioned in this diagram, I mean in the slide and in the next slide. So this is the melting process, in which what happens, liquid is converted in, sorry, solid is converted into liquid without change in temperature. This is really important statement what I wanted to explain to you. देखो होता ये है कि when you are going to heat up a substance, I told you that there were two types of energies inside the liquids, sorry, inside the substance. One, the kinetic energy of the substance. Here I will write about that. Okay, molecular kinetic energy is there. Molecular kinetic energy. And second energy what the molecules possess, that is the molecular's uh, potential energy. The second one is molecular's potential energy. Okay, is it clear? The molecular kinetic energy is purely temperature dependent. Yani, when you will increase the temperature, the kinetic energy of the molecules will increase. When you will decrease the temperature, the kinetic energy would decrease. So it is temperature dependent. Remember one thing. And potential energy is basically intermolecular force dependent. Intermolecular force dependent. Okay, is it clear? So, as you know, that when you will heat a substance, its kinetic energy increases, so its temperature increases. But when you further heat it up in solids, we need to increase the bond, yeah, intermolecular distances, so we make them weaker. So solid to liquid conversion में क्या होता है? Bonds are weakened ना? Bonds are either weakened, or you can say bonds are broken, right? So you weaken the bonds, and here you break the bonds completely. So that energy which is supplied to the system, it is used to overcome the intermolecular forces, that is not to increase the temperature. That is why the molecules temperatures, yani substance temperature does not change. I will, maybe I have mentioned that in any of the slide here. The temperature is called the melting, sorry, this temperature is called melting point of the substance. For a pure substance, melting point occurs at a definite temperature, fixed temperature. The reverse process is this all is fine. The important thing what I wanted to write over here, during state change, this question is asked to you. During state change, thermal energy provided, thermal energy provided is used to weaken the bonds, yeah, to weaken the intermolecular forces rather than increasing the temperature. Used to weaken the, or you can say to overcome, you can write both of these words, overcome intermolecular forces, intermolecular forces rather than increasing their kinetic energy. So temperature remains unchanged. You have to, if it is possible, you can note it down. Otherwise, I will send it to you, these notes, and you probably can remember it for you. So the temperature remains unchanged. Okay, is it clear to you? Is it clear to all of you?
Sir, can you explain this a little bit more?
Yes, I'm saying that the heat supplied, it performs two things. Yani it does two jobs, right? What are those two jobs? First job is it increases kinetic energy of the molecules, which results increase in temperature. Got it? Is this first job clear?
Yes.
थोड़ा थोड़ा क्लियर है या सही सही क्लियर है? Okay, let me write here because I have space here. So heat, yani during temperature change, what happens? There were two setups of the thermal energy na. One consequence of providing thermal energy was, when you were providing thermal energy, temperature was changed, है ना? Only temperature was changed. Yani liquid is heated up, solid is heated up. They are not melting or boiling, is it? Do you agree?
Yes, sir.
So during temperature change, what happens? Only kinetic energy is changed by thermal energy provided. Is it clear to you?
Mm-hmm. Igcse.
Okay. And no energy is used to weaken or break the bonds. ठीक है ना?
ठीक है.
That's why, that's why state does not change. Now is it clear? State of the substance does not change. Our state of matter does not change. If the intermolecular forces are weakened or broken, what will happen? State will change. Na? Do you agree, everyone? So during temperature, yani during temperature change, this is haram for thermal energy. Kinetic energy does not do this purple color writing, whatever I have written here. This is not done by thermal energy provided. But during state change, the first consequence is not there. State change में energy क्या करती है? It only emphasizes or only works on the bonds, not on the kinetic energy. So that is why I will just write that during state change, when state change is taking place, na? So during state change, kinetic energy just work on, sorry, thermal energy, not kinetic energy. Thermal energy, thermal energy just works to weak, weaken the bonds. ठीक है? So no change in temperature takes place. Is it clear now?
Yes, sir.
Clear to all of you? ये जैनब ने तो हिम्मत कर ली, पूछ लिया। ये दोनों बाकी पूछ भी नहीं रहे हो और क्लियर पता नहीं है या नहीं है। इसकी ना एक छोटी सी एग्जांपल है, मैं आपको बताता हूँ। डिड यू एवर यानी ऑब्जर्व के व्हेन व्हेन देयर इज सम सॉर्ट ऑफ यस, मैं आपको एक मजे की बात बताता हूँ, चलो स्टोरी सुनाता हूँ। इफ द क्लास entirely does not want to have a lesson, वो क्या करते हैं?
रोते हैं.
रोते नहीं है। टीचर को बातों में लगा देते हैं, कभी सर ये आज ये वाला, हाँ,
They all skip.
नो नो नो, ये भी नहीं करते। दे आर इन
हमारा
द
क्लास तो
क्लास,
यही करते हैं सर. वेल हमारा क्लास नहीं,
स्केप कर देते।
एफडी वाले स्टूडेंट्स यही करते हैं. हमारे
यस,
होते हैं.
तो बेसिकली क्या होता है कि दे विल जस्ट वर्क ऑन, only they will work on detracking the teacher. They will not work on their own energies. क्या करेंगे वो? They will engage the teacher in any other discussion other than the subject or another other than the topic. So they are utilizing all of the energy on one purpose, right? So when that would be fulfilled, then they have no need to use their energies on that one, यानी to engage the teacher. Teacher engage हो गया, for example आपने politics का कोई topic discuss कर लिया. Nowadays teachers used to take part, eagerly in that all discussion. तो बस हो गई बात, फिर क्लास पढ़ ली आप लोगों ने, तो क्या होगा उसके बाद? आफ्टर 10 minutes you people will have no need to waste your energies on the discussion or engaging the teacher. The teacher will waste his energy or her energy to convince you that which party is right and which party is wrong. Then you will just waste your all energies with gupshup with each other. That's it. Simple. बात समझ आई है?
Yes,
Yes,
sir.
sir. Thanks for the life-changing tip.
Yes, it is a life changing tip for you. Yes, but don't apply that trick to me because I am telling you the trick, so I must have the solution of that also.
No, don't worry, sir. This will be useful during chemistry with
Oh,
my
Yes.
teacher. Don't worry. It's
Okay.
good.
So, अब हम लोग यानी is this very clear that when temperature change is required, all of the energy works, yani all of the heat energy works to change the temperature. When temperature is changed and the time is to change the state, then all of the energy is utilized to weak the bonds or break the bond. So state changes takes place. Okay.
yes, sir.
Okay. Now there is a there is another topic which is actually related to boiling. That is evaporation. That is evaporation. So in evaporation, very interesting topic. Evaporation does not takes place at your at the boiling point. It takes place at every temperature, right? And it takes place only at the liquid surface, right? Is it clear to you?
Yes, sir.
So when it is not taking place in the entire liquid, and that takes place only on the surface of the liquid. So I think we have discussed that topic earlier, evaporation wala, है ना? I have some doubt because I told you some of the life changing tips here as well, that those molecules which would have more kinetic energy, they would come to the surface and then they would leave the surface. They will not be able to held by the other molecules, etc., etc. Maybe I have taught this to someone else, but anyhow, let's move on because you people were not there. So boiling and evaporation involve the change in the state from liquid to gas, but the liquid boils at the definite temperature, which is called your boiling point. But what happens to the evaporation? Evaporation takes place at all temperatures. एक क्वेश्चन आता है in which you people are supposed to write the difference between evaporation and boiling. ये बात याद रखनी है. That question is important. And evaporation takes place only from the exposed surface, yani upper surface of the liquid, while boiling takes place in the whole liquid or throughout the liquid. अब होता ये है कि let's say, check this one out. These are the molecules here. Let's say these are the molecules which are energetic molecules. They have moved up because when I will reach to the conduction convection, then I will let you know that how they are moving to the top of the surface because they are gaining the kinetic energy, and due to kinetic energy their density decreases and they are moving upward. And when they move upward, now they are more energetic than rest all of the particles. When they are more energetic, what happens? The other particles are not able to hold them. When the other particles are not able to hold them, these particles leave the liquid. That's it. Again, एक क्लास की एग्जांपल आप लोगों को दे सकता हूँ. If there is a naughty student in the class, very energetic student in the class, and that student is creating a lot of problems for the teacher like me, so I will try my best to hold it in the class. But once that level would be crossed, when I will not be able to hold that guy, what will happen? Yani, that guy will escape the class, right? So what will happen to the remaining molecules, remaining students? The remaining molecules have less energy. Okay, they have less energy, So they will just settle down. Settle down mean they were not that much naughty. So they will just consider themselves, oh yaar, इसके साथ ये हुआ तो मैं चुप होके बैठ जाता हूँ. Basically, this causes the temperature of the liquid to be decreased. That causes the temperature to be decreased. I will talk about this in detail any in my maybe in the next slide. So these are two different opinions here. The boiling is a quick process, bubbles formed in the boiling that occurs throughout the liquid and occurs at the temperature boiling point, and source of energy is needed. Without energy you cannot do that. So these all points are very important for the boiling. And for evaporation, it is not a quick process, it is a slow process. Nothing is visible. Yani, when we wash the floors, what happens? क्या करते हैं हम लोग? फैंस ऑन कर लेते हैं, and we could not see where the water is disappeared. तो वहां पे आपकी visibility नहीं आ रही ना. And then occurs only on the surface and occurs at all temperatures. Even in winter, evaporation takes place and energy supplied from the surrounding. So this is basically the major slide for you people, in which I have compared evaporation and boiling. So I am just going to give it a title: comparison of boiling. And any question?
No, sir.
Very good. I need these type of students who don't have any question. Okay, so I will write two, three more important points. They are factors affecting boiling. Sorry, evaporation. Factors affecting evaporation. What are the factors which affect the evaporation? There are, the first factor is surface temperature. If you ever see the steam above the hot cup of tea or hot cup of coffee,
Yes.
Yes, sir.
very good. Why did you not see at the cold cup of coffee or above the water or cold tea?
I mean,
Cold
sir,
coffee पीते हो ना?
technically you do see steam in that kind. There's a specific kind of ice, dry ice, in which there's smoke
Dry
coming.
ice. Yes. But the problem is, when you put hot cup of tea in okay, I will talk about that in another factor. So those liquids whose surface is more hot, more temperature, there would be more energetic molecules on the surface of the liquid. So they would leave more quickly. So evaporation, evaporation rate, EVs, R stands for evaporation rate, is directly proportional to what? Is directly proportional to the surface temperature. You have to remember this point. Secondly, the evaporation rate is, second point, that evaporation rate is directly proportional to the surface area. Surface area. Okay, I will give you an example of that. How many of you are aware that in the morning, if you people are getting late, you just put the tea or the milk or whatever you take, the hot drink in the morning, you put it in the open container or just like a saucer or in a big surface area plate. How many of you are aware of this? ठंडा हो जाता ना जल्दी,
Yeah.
right? So if you want to make some liquid cold quickly, cold quickly, तो क्या करोगे? You will put that in that uh, container or that uh, yani utensil in which the surface area is more. So more of the liquid is exposed to the surrounding, so it would evaporate quickly. Is it?
Yeah.
And that is the why you spread your cloths on the roof, so they are exposed to sunshine, as well as they are exposed to wind, as well as their surface area is more. So these all factors collectively draw your clothes. ये बात समझ आ रही है? So
Yeah.
that is a question, that why do we spread the cloths instead of just making them damp at one point? So that increases the evaporation, and then evaporation will result drying of that. Third one is the difference of surface and surrounding temperature. Surface and surrounding temperature. This is very interesting, and I will request you to just to do this experiment. Uh, if today or in 1 or 2 days before, you will forget about the evaporation technique, and that is just put a hot cup of tea in the freezer section of your fridge, freezing section of your fridge, and just notice what is happening. Did anyone do that before this?
No, sir.
No, sir. My mother
Yeah.
would put me in the
क्या
freezer.
करते हो तुम लोग शरारती बच्चे? हाँ.
My mother would put me in the freezer. Dare I touch her beloved freezer?
Yes. So you know what will happen? Evaporation rate would increase, and yes, for example, this is a hot cup of tea, and you are just putting in the freezer section. So there is a physics behind it, and the physics is the uh, the temperature of surrounding is very low as compared to that of surface. Here temperature is more, right? So due to that, more molecule would leave the surface, right? So after some time, what will happen? That that this evaporation would decrease. That's why we, when we put the liquids in the freezer, mostly evaporation and convection helps us to cool them down, not conduction and convection, because mostly the utensils are of ceramic. बात समझ आ रही है? So ceramic is not a good conductor. ठीक है? And fourth factor is humidity. Humidity is basically that factor which defines that how many molecules are already in the surrounding. In the humid environment, evaporation is less. That's why in the monsoon season, it is very difficult to dry the clothes. And we feel just wet face. ये जो oily सा नहीं हो जाता हमारा skin, just moisturized skin होता है. That is in humid environment, right? So evaporation is decreased in humidity, is inversely proportional to humidity. Rather, it is directly proportional to drought. How do you pronounce it? Drought or drought?
Drought. Drought.
Spelling सही है?
Yes. Yes.
Yes. So that is why, you know, when there is no humidity, you people have to use some moisturizers on your skin to keep it just uh, क्या कहते हैं उसको, moisturized. मेरी अंग्रेजी इतनी है ना, तो इसलिए ठीक है. And the fifth factor is nature of the material, nature of the liquid, nature of liquid. So when you talk about nature of liquid, आपको पता है क्या होता है? The volatile liquid, just like your petrols and uh, uh, just like spirits, they evaporated so rapidly. Okay? So volatile liquids, volatile means whose cohesive forces are less. Volatile liquids evaporate faster. Just like petrol, not diesel, petrol. Crude oil is not volatile. Okay? Is it clear? That's why we are advised to recap the markers because they are having some sort of uh, organic compound. I just forgot about that. But most of the organic compounds are volatile. Most of.
Got it, sir.
Okay? Is it clear to all?
Yes, sir.
Yes, sir.
Okay. Good. And one more good news for you that from these notes, this is not in the topic. This is excluded from the
Sir,
syllabus.
I remember doing it last year, but I'm so happy it's excluded.
Yes. Latent heat is gone. Okay? Specific latent heat is gone. So these all, I believe that, yeah, melting and boiling curve, I will let you now because this can be asked to you. This is important topic. Just go through that one. That what happens? This is the graph of temperature versus your time in seconds. Check this one out. It is temperature versus time in seconds. So if you see, initially a solid is heated. Step number one, solid is heated. When you heat up a solid, you know what happens? This is in the solid state. This all is in the solid state. आपको 10 minute में complaint cell. Okay, so here, did you see some of the some of vibration is being observed in the molecules? A vigorous vibration is being observed in the molecules. This means that now they are trying to deform. Here they are in the solid and they are being and they are in the process of deformation. So check, temperature is not changed. So here the substance is in liquid and solid both states together. Is it clear to you?
Yep.
Yes, sir.
And in stage 3, this was I was explaining stage 2. Stage 3, in stage 3, yani all of the substance is now into liquid and liquid is heated. So here it is mentioned, liquid is heated. Yani, yeah, liquid is heated. You are heating a liquid. Is it clear? And here at this stage, some of the molecules are in liquid and some of the molecules are independent. So this is the combination of liquid state and gaseous state together. So until unless all of the state is not changed, temperature does not change. This was very important point. Why I skipped it? I had to mention here, here. Yes. During state change, during complete state change, temperature remains unchanged. Temperature remains unchanged. So, in that situation, what I have explained to you here, in this stage, stage number 4, some of the molecules are in liquid, some of the molecules are in gaseous state. That's why temperature is unchanged. So, this straight line shows temperature is unchanged. And here, this is basically the gas, and now you are going to heat up the gas. So this is basically this point is boiling point, and above that, this lower one, this was the melting point. Yani at this one, this was the melting point, temperature wala na. Did you see? Here is that. Actually, this line is here. So that is the boiling point, and that is the melting point. That's it. And here is the gas. So this slide is really, really important for the state change, right? I mean heating curve. It is called heating curve. So when you go to the reverse of that, there is the cooling curve, and again it has the same mechanism. So I believe that you people will get it. Yani it is yani reverse process of that. So everything is same, but first the gas is cooled down. So during this condensation takes place. This is the process of condensation, and then all of the gas is converted into liquid. So gas is liquefied. Liquid is cooling through this, and now liquid is just freezing, right? Liquid is freezing, and at this point entire liquid is frozen. That is its freezing point, and then now it is solid, and solid is now cooling down, right?
Yes, sir.
Um, yes. These are some sort of areas what I have discussed earlier. Calculating specific latent heat, cross it. It is not included in your syllabus. And from here, there are your questions started. So from slide number 54 to just you have to leave all the latent heat questions. Rest all of the questions are your past paper questions. ठीक है ना? ये सारे आपने करना है. Yes, here
ठीक है
is the third state or third aspect of providing heat to the substance. That is, I told you that once you are heating a substance, its temperature would be changed. Secondly, when you are heating the substance, its state will be changed. And third, when you are heating a substance, its volume will be changed. So, isn't it a sequential method? Temperature, state, and volume. So, when we are at this stage, that volume is changed. It is called expansion, right? Or compression. ठीक है जी? So, thermal expansion of solid, liquid, and gases. Actually, a question comes from this one as well. A question is asked to you. So thermal expansion mean when you are going to heat up a substance, its volume increases, and this increase in the volume is called expansion. And when you cool down a substance, its volume decreases, and that is called contraction. Contract होता है substance. ठीक है, not compress, contraction takes place. Now check this one out. This is actually a this is the liquid that expands when it is heated. This is the liquid, and when you expand the liquid, just it reaches to this point. So it is more heated, it is less heated liquid. And here in the solids, did you see, if you want to fix that, its hole is small, but when you heat it up, what happens, it expands, and its hole is enough to fit the axle inside. And in this way we make this joints and riveting. I will explain it in detail, but check this one out. There are two bullet points. Thermometer works because the liquid inside them expand and rise up in the tube, which when it is heated. Metal parts, they can be fitted together without welding using the shrink fitting method. Shrink fitting method mean when you cool them down. For example, if you are cooling this axle, it will be fit in it. Or if you are heating this, it will be expanded to fit the axle inside. So these are the ways in which we will talk about that in detail. So here is basically the detailed expansion of a detailed discussion of that. That when you are when you heat up a system, what happens, the space between the molecules increases. That causes the increase in their volume. So expansion is very small in liquids. There is a question that expansion of liquid is least, then that of expansion of, sorry, this was the solids. Expansion of solids is least, then expansion of liquids, and then expansion of gases. So gases expand at very high rate. In the same way, compression or contraction in gases, contraction or compression in the gases is largest than that of liquids, sorry, that of liquids, and then that of solid. So solids and liquids are at your level, they are considered, they are not compressible, incompressible, incompressible, but gases are compressed, right? So at this slide, this all is being discussed, because gases have more space, so it is quite easy to compress them, and they have very small intermolecular forces. That is why very easy to expand them. Okay, so expansion of the liquid is some, interesting. Liquids are expanded in this way. Check this around. First, when you are going to heat up a liquid in a container, first container will expand, right? What will happen? First container will expand, so liquid water will decrease. मैं आपको ऐसे बता देता हूँ, easy way में हम लोग कर लेते हैं. Yes, this is very interesting. Flask X is at ordinary temperature, right? There is a liquid, glass tube में डाला गया है, so that you can observe it significantly. When you are heating this, glass flask is expanding. When it will expand, the liquid of the level of the liquid will decrease. So initially it decreases, and then it expands more. Is it clear to all? देखो ना, this is due to expansion of the flask. Expansion of flask. It is very easy to understand. This is the ordinary level of the liquid and ordinary volume of the liquid. It is volume 1 of the liquid. This is volume 2 of the flask. Because till this point, only flask had got the heat. So flask will expand. So the liquid which is out above it, it would fall down because it has more space now. That's why the level of the liquid decreases, and now flask has been expanded, or it has extended to its ultimate level. No more expansion takes place. Now the heat has reached to the liquid, so liquid has more expansion, so that's why the liquid level has been increased to that point. So this is actually the real expansion, sorry, this is actually the real expansion from this point to this. Okay. So expansion of the gases is, as I told you, that gases expand a lot. So when gases expand a lot, they can be easily compressed. So this is the reason, unlike the solids and liquids, all gases expands equally. The expansion of the gas is more greater than that of the solid and the liquid. So it's an easy slide, no issue at all. So this is the comparison of the expansion, as I told you, because gases have almost 30 times more expansion than that of the liquid. Liquids have almost 20 times than that of the solid, and solid is the standard. The reason behind that, they have weakest intermolecular force, they have fairly strong intermolecular force, and they have very strong intermolecular force. So intermolecular force does not let them to expand. Is it clear to all?
Yes.
सोना नहीं है, ठीक है. Then thermal expansion
Yeah, could you explain
consequences
it
are
one
there.
more time?
Yeah, if I say that why it is difficult for the solids to expand, because they have very strong intermolecular forces. So when they have very strong intermolecular forces, their molecules cannot be detached from each other. Is it? In liquids, molecular force is strong but not stronger than that solids. So that is why it is quite, it is easy to expand them. But in gases, the intermolecular force is very weak. So molecules are not related, I mean, they are not affiliated with each other. They are not interacted by each other with intermolecular force. So they are free. So when they are free, they just get very small energy and they expand. Clear?
Yes, sir.
The last aspect is the disadvantages and advantages of the expansion of the solid. Did you see that this is a railway track and there are some gaps which are placed in between the railway tracks, mean the those metal girders, those tracks, because if they would not have those gaps, what will happen? This is the without gap. So when temperature would increase, these tracks would bend, and when the tracks will bend, they will cause severe accident of the rail or track, I mean train, railway track है ये, ठीक है? So bending takes place. Here is this is one of the expansion. So when expansion will takes place, what will happen? They would become free if they are of different metals, right? There are the gaps so that देखो, these are there are the gaps in between these two. They're not joined together. So if they would not have these gaps in the winter and in the summer, their yani their distances would be changed, and that can make a problem for the purpose for which it is being used. Then these are, yes, this is the internal structure of those bridges which are used for overhead bridges. Naval Anchorage wala bridge, Zainab, if you remember.
Ji
Yaad hai
sir.
na? Yes. So when you people drive on the bridge, there is one part of the bridge in which metal strip is there. Did you ever notice? There are some metals inside the concrete at the top. You can see them. So they are actually having the metal throughout. So they are just to manage the expansion and contraction of the pull, these bridges, right? So if you will not uh, make it flexible, it would cause the cracks in these concrete slabs. So these are some sort of you know discussions about advantages. How many of you have visited the snowfall areas during snowfall? How many of you?
Sir, I have.
Okay. Did you ever see the broken wires at these high transmission voltage wires
Mm-hmm.
anywhere?
Ji sir.
Yes. So there is a reason, because these are the aluminium wires. So from one pole to another, what happens? They have they are contracted when the temperature falls. Now, what happens? They have a contraction. When they contract, they cannot withstand the tension which is being produced because poles are stiff. They are not being flexible. Some in some of the areas, the poles are toppled over because the wires are having a lot of force from the other pole because they are contracting, and if the base of the pole is not good, so the poles would topple over. Otherwise these wires would be broken. That's why we put some sag in these wires. In ye dekho, these are not fully tight. There is a sag in the wires. Okay, they are kept a little bit loose so that in winter, when the temperature would uh, decrease in the cold areas, they would not be broken. Okay. And the last example is the bimetallic strip, which is excellent use of thermal expansion in your electric iron, right? In your electric iron, in your microwave oven, in your fridge, in your there are some other, I just forgot about that. There are two metals, they are pasted together, and yani they are basically welded together, and they are put under the same uh, temperature level. This is copper and iron. When they are unbonded, copper expands more than that of the iron, and when they are bonded together, they would cause a bend, right? Copper expands more, so that metal which expands more, it would be at the outer side of the curve, outer side of curve. And that metal which contracts more, that will be on the inner side of the curve. ये भी बड़ी मजे की बात है. This contracts more, yani this golden copper is that contracts more. When it is placed in the cold room, then this would contract more because it was expanding more, so it would contract more as well. Okay. So this was basically one of the situation. Electric iron, when you will heat it up, what will happen? It will bend. And yeah, this is a fire alarm. In fire alarm, when temperature increases, this metallic strip bends and it makes a contact. And when it makes a contact, what happens? It rings the bell. Simple, simple circuit hai. It is just a use of that. Yes, this is the thermostat what I was talking about. Yes, thermostat से मुझे याद आया, गीजर, गीजर में लगता है. It trips above a specific temperature, right? This is the tripped bimetallic strip is there, right? Heater is off because uh, you know, in electric irons, when you heat them up till a specific number, they just switch it off. They switch off because the connection is broken. And here, when again the temperature decreases, this bimetallic strip is yeah, it becomes straight, and when it becomes straight, it is in contact with the power supply, and that provides a current in the heater, and again it is heating it up. So this is a concept of bimetallic strip. Yeah, thermometer we will discuss in the next lesson, inshallah. And not thermometers are actually excluded from the syllabus, but the only thing that thermometer is the application of expansion, liquid expansion. That's it. Okay.
Okay, sir.
Yes. So these all are the topics. Yeah, bimetallic strip का देखो question आया है ना? Yes, this is that question. What? Oh, wow, wow, wow. This is the question what I was asking to you. Yani what I have drawn. The diagram shows the bimetallic strip when it is at the room temperature, right? And after it has been cooled. So जब cool किया इसको, the chain in the shape occurs because which contracts more, brass or inner? I told you that cooling process में, which would be inside the curve, it cools more, it contracts more. ठीक है? And heating process में, that expands more, that will be on the outer side. ठीक है?
ठीक है.
आप लोगों को ये क्वेश्चन सारे, या these are for the rail sections tracks. ये क्वेश्चन आपका यहाँ पे आएगा, लिक्विड एक्सपेंशन ये आएगा, गैस के एक्सपेंशन का क्वेश्चन ये है. There are yes, this is that question. When heated, bend in the direction of sound. So what does it show? That x bends more, x expands more, right? So x expands more. So aluminium का उसने बताया हुआ है. That's it. So this entire slide is equipped with notes as well as your past paper practice questions. Okay? So I believe that you people will cooperate with me and you people will try this. Okay, ji?
ठीक है, sir.
This getting late in the class started from my class number 2 today. So that chain reaction still existing. अब मैं अगली क्लास से काफी सारा लेट हो गया. तुम लोगों की क्लास में तो मैं 45 46 पे शायद आ गया था, है ना?
जी सर.
48 तक आया था, yes. But I have to now skip it. Okay, ji, is it all clear to everyone?
Yes, sir.